Here's an example of an empirical rule question. So women's height have an average of 65 inches, standard deviation of 2.5. So my advice is the very first thing you're going to want to do is you're going to want to label that on your normal curve. So the 65, draw 3 lines each way. Okay, and then we're asked a question about between 60 and 67.5. This one's kind of tricky. Let me grab some colors. So let's first kind of remind ourselves about the rule. And again, I'm going to give you the rule here, because if you're afraid you're going to forget those numbers, you'll be all right. So between one standard deviation, there's your 68. So I'm going to draw it up here. So here's my 68. And then we kind of talked about in class, if you would extend forever each way, you would do 100 minus 68 divided by 2. So there'd be 16 here and 16 here. That adds up to 100. Okay, and then let's do green. So the 95% is going 2 standard deviations. So there's my 95%. Let's see, I'll draw it down here. So this is 95. And then to get to 100, we need 5 more percent. So that means this would be 2.5 and this would be 2.5. So let's see if we can answer this question now. What's the probability a woman is between 60 and 67.5? Okay, what did I do? I know these are both 34, right here and here. Those add up to 68. And I'm trying to get from a woman who's 60 to 67.5. So I have, this is 34, and then do you see why I had this part here is 47.5? I don't know, there's more than one way you can do that. It's kind of like half the curve minus this 2.5. That's my 47.5 plus a 34. There's more than one right way to do it, but the answer is 81.5%. Okay, a woman is shorter than 70 inches. Okay, this one should be pretty easier. Let's think of taller than 70 inches is only 2.5% of women. So shorter than 70 inches would be 97.5%. And a woman is taller than 67.5. Okay, we can use one of these arrows up here. So here's 67.5, taller, 16%. So do your best on those. I will give partial credit if you at least have everything labeled here, but I think you'll do great with that. Okay, let's practice z-scores. So less than 1.54, I'm going to ask you to sketch it on purpose because you're more likely to get it right. So the probability that our z value is less than 1.54, let's kind of do one of these at a time here. There we go. Okay. Notice if 1.54 is positive and we want it pointed to the left, so you want to have a big answer, so look on the big side of your sheet and you should get 0.9382. All right, the next one wants to know, it's the opposite question, greater than 1.54. Well, that's going to be everything except 0.9318 or 0.9382. So you could take 1 minus that to get your answer, or you could look at the negative. Whatever you want to do, but the answer is 0.0618. Okay, now I'm asking you to shade between negative 2.13 and 0. In between those. So z is 0, that's right in the middle, negative 2.13. So my advice when you do these is you look up the bigger number first. So when you look up a z-score of 0, you guys should already know that's 50%. And then you look up this percentage, which is the negative 2.13, and anytime you're finding in between, you take your bigger answer minus your smaller answer. So 0.4834. And finally, these are both positive, so you want to look up both positives. And we're going to get a small answer as our final answer, it's just that shaded region there. But notice both of these answers were big to start out. So if you look up 2.5 first, you get 0.9938, and then look up positive 1.2 and you get 0.8849, and you subtract. So again, you're going to do this on your test, very similar. You're just going to look up things on the z-score sheet. Okay, number 5 and 6 go together. And we know the battery life of a watch has a mean of 28 and a standard deviation of 5. So this one I'm just going to write my 28 and my 5, like the shortcut way. The only time I think you need to write all of them is if you do the empirical rule. But once you get beyond this question, let's just do how we've been doing. Just write your mean and your standard deviation. Okay, what percent of watches last longer than 3 years? Well, remember, this is months. So 3 years, you got to turn into months. Maybe I'll write months down here. You guys know 3 years is 36 months. Okay, so what percent of watches last longer than 3 years or longer than 36 months? You got to find that z-score. So remember to do z-score. It is 36 minus 28 divided by 5. And I wrote my z-score right here is a 1.6, and I want just a small answer. So you could look up a couple ways. I would probably just look up negative 1.6 because I think that's easier. So 0.0548. How many months will the worst 10% of watches last? Worst 10%. Do you agree? Are the watches that are breaking down here? So if they give you a percentage first, your goal is you find the percentage and what z-score matches up with the percentage. So on your z-score sheet, you guys can write what, this is your sheet, you can write whatever you want on this. These obviously are labeled, these are the z-scores. All these numbers is your, if you want to think of this as percentages or probability. So if we want the worst 10%, I don't want to be on this side. This would be like a high answer. I want the worst 10%, so this is like the bottom 10%, and z-score is not a percent. We want to find the z-score that gets us close to 10%. So I'm just going to kind of search through here. Remember, 10% is 0.10, so kind of here we're getting closer. Oh, that's really close, right? 0.1003. And then you look, all right, what z-score leads us to that? Negative 1.28. That's your z-score. Your z-score is negative 1.28. And remember our formula, z equals x minus mean divided by standard deviation. So what we don't know is the x. That's what we're trying to figure out. But we do know the z-score, so negative 1.28 equals x minus 28 divided by 5. And remember, you just cross multiply. So I'm going to type in my calculator, negative 1.28 times 5, negative 1.28 times 5 plus 28. And I get 21 point, can you read that? 21.6, and then that answers months. Do you agree that would be the worst batteries, the ones that only last 21.6 months? Okay, let's review. We talked about this in class. Parameters, you would use the Greek letters. In statistics, you use just X bar and S. From the penny jar lab, this would be the whole jar. And these would be numbers from like when we did like n equals 4 or n equals 25. So kind of just know the difference. That's going to be kind of like a matching section. But just know parameters would be population and statistics would be sample. So review that. I will give you this formula, but remember you use this when you're going to take an average of a group. So like we're going to find the height of 4 men, or we're going to find the average penny age of 16 pennies. That's when you do this formula. Okay, so let's talk about number 7, and these all go together. Coals carried from a mine in West Virginia. The car loader, 75 tons of coal in each car. Like that's what is supposed to set. So that's our mean, and our standard deviation is 0.8. What's the probability of one car? So one car, we want to use the normal, the 75 and the 0.8. Okay, and that's my normal curve. What's the probability of one car chosen is going to have less than 74.5 tons? So this is my normal curve, 74.5 less than. So my z-score, I did 74.5 minus 75, that's where I got that, divided by my 0.8. So my z value is negative 0.63. I want the small answer, so I'm going to look on the small side. Negative 0.63 is 0.2643. And you can write it as a decimal or a percent. It does not matter. Okay, now what we have going on is we now have 20 cars. What's the probability that 20 cars are going to have an average weight less than 74.5? So now we have to fix our standard deviation. The mean should still be 75, but the standard deviation is definitely going to change. You got to do your 0.8 divided by radical 20. So now once you have this normal curve, you basically figure out things like before. Okay, let me show my work for my z-score. 74.5 minus 75, but now I'm going to divide by 0.18. And I'm going to get a z-score of negative 2.78. So I'm going to get a really small answer. I did not draw that to scale at all. I should have had like just hardly anything down here shaded, but that's okay. So our final answer is 0.0227 or 0.27%. Okay, now here's one of those working backwards problem. There's a 25% chance the average of these 20 cars is going to be less than what value? Okay, so we're trying to figure out this. What value is this that we're going to have 25% of cars underneath that weight? Do you guys see why we're still using the same normal curve from here? We still are talking about our 20 cars, so we still want to use this normal curve. So do you agree, is this the bottom 25%? Yes. So we want to, and that's a percentage. So we want to look in here for something close to 25%. It's going to be down towards the bottom. There's 25. Okay, so you can kind of choose between these two. It really doesn't matter. You could do negative 0.67 or negative 0.68. I did negative 0.67. That's my z-score. But I want to find what that weight is. So I do z equals x minus mean divided by standard deviation. We're going to type in our calculator. We're going to start with the negative 0.67, cross multiply by 0.18, and then plus 75. And it's about 74.9 or 74.88, and this is talking about weight, so make sure you label your answer correctly as tons.